Good morning, good afternoon, good evening, whenever it is you're watching this video, students. It's Mr. Ramirez. I'm here to show you your Build Your Own Spacecraft activity. It is found in your Google Classroom. If you go to Google Classroom, you should see it, no problem, right? So if we close that out, and it might look a little different in yours, but if you look in the Google Classroom, it should look something like this, but it'll have my video here also included. So make sure you look for that. And that activity is, let's remove myself here. Build your own spacecraft. And it's just what it sounds like. You're going to have a bit of a hands-on activity. There's a worksheet, but it's a hands-on activity using different things to help you build a model of a spacecraft. It's supposed to be fun. It's meant to be fun. So let's get started here and see what we're supposed to do. In your Google Classroom, you'll see that, I'm not sharing this slideshow, but everything in the slideshow is there except for this. You're going to use household items and build a spacecraft or satellite model that includes the basic parts of an actual spacecraft or satellite. Satellite is a very interesting word because it's mostly, to you, man-made. It doesn't have to be, and you should really look at that word. You should really research that word. It's a question on the worksheet, and it's something that I really think you need to take a look at. Spacecraft, you think of spaceship, you think of a space shuttle, maybe even think of rovers like the ones that are on Mars. So those are things that you also may want to build as a model, okay? So the first thing you're going to do is you're going to go to this website here. It's in your Google Classroom, right? It's going to take you to this right here. If it does not take you to this, or you cannot find your way through that link, you're looking for Space Place right here. And there's the link again. Just copy that into a web browser. Okay. The website, like I said, looks just like this. If you scroll down, you'll see lots of stuff that we're going to cover right now. But it also has possible ingredients here, materials that you can use. We're going to focus first on the parts of a spacecraft or satellite, right? So you're an engineer. Engineers build things. You're gonna be a NASA engineer. You're going to think of, through this activity, the latest and greatest satellite or spacecraft that you can create. They want you to use it to take pictures of planets in the solar system, right? And you go down, it has this nice little model with these different parts. 5 basic parts, okay? 5 basic parts that you need to figure out what you're going to use to create. The first being a container. Okay, this yellow piece here is a container. A container holds different things like a box or a yogurt carton or a carton of some sort is a container. So in this case, a container is going to hold all the gizmos and everything together. What can be a good container? Well, if I'm using non-edible material, this is a pretty good container. It's a plastic cereal bind, but I can put toothpicks or other sharp things. Be careful. We're going to be very careful. You always use safety when you talk about these things. Okay, but you can put it through this container and it'll hold something. So the container is holding everything inside of it. Usually they're metallic or metal or something very strong, because in space, we know the conditions of space are very tough to live in. So humans can't live there, but also electronics and everything of that sort has a lot of trouble staying workable in that. This can be a container if you like, right? You can use a deck of cards or a card box like I have here. If you're thinking of edible, you're gonna make it so you can eat it after. Remember, like we did with our graham cracker homes or gingerbread homes, you don't wanna handle that stuff too much because you wanna eat it. We don't wanna waste it. But I can use this chocolate bar. I can use it without opening it, and I can stick toothpick things inside of it. If I really want to get super big, I use a fork, right? Plastic forks are good, or break it, but be careful again. We don't want to cut ourselves, but those are good things to use, right? Different items I can use to put together. If I want to make it purely edible, that's a challenge also that you might want to take, or purely non-edible. Okay, that's another challenge you can do for yourself. But these are always, these different things are containers that I was able to just, look around the house and find, okay? Power source, see this power source right here? Power source is usually what? Raise your hand. No, you can't raise, I can't call on you, it's a recording. A power source, you might be thinking right now, is solar panels, batteries, an electrical cord plugged into, something that gives it power of some sort, like a fuel cell or anything like that. That's a power source. You need something to get your satellite some electricity so it can run all of these high-tech gizmos that are found around the container or inside of the container, okay? Scientific instruments or science instruments. This right here, this little box does something. These little things here do something. They do whatever you want them to do because it's your engineering product. You might want to be able to explain what they each do, but for our purposes, we're just thinking of having any type of instruments because that's why you launch your satellite or spacecraft into space. You want it to take pictures, it has to have a camera. You want it to take some readings of far off galaxies or Saturn's rings, or what is it like on Pluto or Mercury. You have to have scientific instruments. Communication device is usually round because it's usually what? What do you think of when you think of a communication device? Anybody have something on their roof that is used as a communication device so that they can watch cable or what we call satellite TV, right? It's usually rounded. So this can be something that can easily be used as a communication device model, right? The cap of this bottle here can be used, glued to on or used somewhere to say that's my communication device. Okay? Anything like that is usually, but again, it's your imagination, it's your creation, it's your engineering product. Orientation finder. Orientation finder. Orientation. What does orientation mean? What do we mean when we orient, right? Or orientate, that's not a word. Something. We usually think of maybe a camera, something that points and is used as a device to tell you where to go. Orientation is talking about which direction or which way you need to be going, okay? So make sure you have something that tells the satellite or spacecraft where to go, right? Star tracker, sun tracker. The sun and the stars will change very slowly in position, so it can always use those to keep itself focused somewhere. The front of this, or top of this water bottle, sorry, can be cut very carefully again. Ask someone to cut it for you, an adult, if you can't do it yourself. But if you want to use it, that looks a lot like an orientation finder. So, examples. I don't want to give you I don't want to show you the examples. Yeah, I know you're on the website anyway, you can see it yourself, right? I don't want to show you because, sometimes people will look at things and say, hey, that's a good idea, and then they copy it. Let's not copy it. Let's use our own engineering. Okay, use your own imagination. Container, this juice box, toothpick. Okay, these cups. Oh, we have a lot of these cups at school, right? You might have some at home, a screw. Okay, is this the communication device or is this the communication device? Right, they do give us the definitions there, but really your own imagination, whatever it is you believe you would like to use. Okay, no power source. Where's the power source? There's no power source sticking out like there is here, right? Doesn't have to. They use this glittery tape or you know, reflective tape here to say those are their power sources. So your imagination, this one, well, some of you might laugh and say, oh, look at that. That's so simple. No, it's, they have every part that they need. They have their communication, right, device. They have scientific instruments, right? Here, they have orientation finders, power sources, the container, right, which is the main portion of this whole thing. Okay, this again, very simple. Some sponges, the screws, and, you know, washer. Your family probably has a whole bunch of these somewhere, you know, to be used or that were never used. There's some more reflective tape. Okay, very, very, very simple, but you have to be able to explain what your parts are. These old things right here, you should ask somebody what those do if you don't know. Some of you might think they're video games, like PlayStation games or something. Yep. And, you know, look here, more screws. Those are eyelets and such, and wood and paper clips. Your own imagination, students, your own. Okay. They have some examples here when I ask people on the question on the worksheet to give us some examples of satellites. These are some examples. These are pictures. But how about you go out and research, find your own YouTube video, pictures, or something, right? Because that's what you're asked to do on the worksheet. So let's take a look at the worksheet very quickly. Okay, so you're supposed to turn in this worksheet and a picture of your model, but these can be put together. Okay, what are the different parts of a spacecraft? What does each do? I think that this website right here is very helpful in that. Okay, what is a satellite? Like I told you, that question, it's a very good question because it's not just what you believe. I want you to explain, give examples of satellites, but you should really look at this word, pay attention to the different examples they give you. Picture or video that shows an example of a spacecraft or satellite posted here. Be great if it came from somewhere other than right on that website, because it's easy for us to just look at these. How about we go find one that's not here? How about you go find a video of the Hubble spacecraft, and then it can explain what it does a little, right? And make sure you watch it. Don't just share it, watch it. So the information here is from your Space Place site, which also is there where you create your product. Using your best engineering skills, what materials do you plan on using? Tell us first what you plan on using. Don't just tell us what you use. Don't just go build it. How about you think about it first and say, these are what I plan on using. And then you can also, you know, at the end, tell us in your reflection, did you use those materials? What are you going to name your product? What are you going to name your spacecraft or satellite? I suggest the Mr. Ramirez, because I'm a good guy and I should be, you should name everything after me, no? Or you name it after just something you like, right? It does not matter. It's your product. It's your name to give it. And then here's one time you post a picture of the engineering product you created. If you cannot share your photo here, share it through Google Classroom as a separate document through the attach and share those. We do not want you to turn in this document without sharing your final product. That's the whole basis of this. We really would like to see it. If you have trouble, we understand that, but we also think there's phones that you could take a picture of someone's phone, email it to yourself, put it into here, share it in a Google Drive. There's many different ways that you can get those pictures, and that doesn't have to just be through your device, but your Chromebooks all take pictures. If you got a Chromebook from the district or the school, they take pictures. So ask somebody, work with that, but we really would like to see a picture, okay? I really think that it would be just a total, you know, sort of time where you say, I make something, but then you don't show it to us, okay? So we really like to see it. Foil is very reflective, but if you use foil for your metal parts, you gotta make sure that your picture doesn't have too much sunlight. Like my glasses, I could see glare from my window here. Okay, and then the reflection is, did it look the way you wanted? Was it exactly, did it go exactly? You know, did you use the materials you wanted? Anything you might do differently next time? Why? Okay, always good to reflect on your work and tell us what you think did and did not go well. Okay, so this is what you turn in. What I've just shared already. You turn in your worksheet that's in your Google Classroom. It's included there already. Upload the picture of your own creation through Google Classroom, either on the document or you do it through the attach in your Google Classroom. So we want to see them. You got questions? Anybody raise your hand if you have a question? Let me see. Of course, I can't see you. It's a video. You can only see me, right? But be sure to ask them during office hours. You can ask through Google Classroom. You can ask any of your friends, your buddies, if you have contact with them, if maybe you need some help with something. But there's plenty of different ways to get feedback or information that you might need or to get your questions answered. So thank you very much for watching. Thank you very much for doing your best to be a good engineer. I appreciate it. Mrs. Nero, Mrs. Luke appreciate it. And I will see you next time we do any of our classes. Thank you very much.